Hello and welcome to Calculus tutorial. We are switching gears away from differential equations to the area between curves. And so hopefully when you see the word area, you will think integral. But this time, instead of the area between the graph and the x-axis, we're going to take a look at the area between two different curves. And so sometimes you'll have a single area that you can look at, but sometimes you will have multiple areas to find. The strategy is pretty much the same, and it's a strategy we're going to be using for a long time. So let's take a look at the area between two curves. So here we have an upside down parabola and a right side up parabola. We want to find the area between them, okay? What we want is this area right here. But we don't have a mathematical statement that will give us just that area. So area means integral. So if I take the integral of the black function, it is going to give me that right there, which is obviously too big. And so what we have to do is subtract off this bottom piece. We need to get rid of that bit, and that will leave us with what we actually want. Well, the mathematical statement for the yellow is the integral of that black function. So let's call that black function f. We're going to take the integral from wherever you start to wherever you finish of f. Minus, now we have to get rid of the stuff on the bottom that we don't want, namely this part. Well, what is a mathematical function for that? Well, that is the integral of the blue function. Let's call that g. G of x. So we're going to subtract off the integral again from your starting point to your ending point of g of x. That will give us the middle section. And so what I usually do is I think of this function as your big one because it is on top. It's above the other one. And I think of this one as the small. Well, if I could spell small, that's embarrassing. Small. Okay, because it's below the other function. So I call that one the small and that one the big, and so this simply becomes big minus small. Because these two integrals are the same, you can combine them as one integral from a to b of f of x minus g of x. So that is our formula that will give us the area between two curves. You simply take the integral of the top one and subtract it from the integral of the bottom one. You can think of it as two different integrals if you want, or as one single integral. It's the same thing. They both work. All right, let's see how that works in practice. Oops, wrong one there. That's the one I want. So let's start with the easier one. If there is one single area between the two curves. That is not what I wanted to click on. Sorry about that. All right. So let's graph these two. If you can't graph them in your mind, that's fine. Graph them on your calculator, but I know what they look like. So 4x minus x squared is a parabola that looks like this. And the other one, x squared minus 4x, is a parabola that looks like this. And so the first thing we want to figure out is where do they cross? And so this is a nice, easy example. They both cross at 0. You can see if you plug in 0, you get 0. So that is going to be our starting point. Where do they cross again? Over here. They both cross at 4. So if you want to plug in 4 to check that, 16 minus 16 is 0, and 16 minus 16 is also 0. They're the same, so they again cross at 4. So now I need to do big minus small. So this one is my big, and this one is the small, because the big one is on top and the small one's on bottom. So the big one was the red, which was F, minus G. And so you can do this as two different integrals or as one. I think doing it as one is easier in this case. So 0 to 4 of F, which is 4x minus x squared, minus, now don't forget parentheses here, x squared minus 4x. And then we can combine like terms. That's another negative, and that one will be a positive. So a negative x squared and a negative x squared is negative 2x squared. And then a positive 4x and a positive 4x is positive 8x. All right, now we simply have to do this integral. I don't really need the graph anymore. Free up some space for myself. All right, so take that integral. This is going to give us negative 2/3 x cubed plus 4x squared, evaluated from 0 to 4. Nice thing about this, when we plug in 0, it's all going to go away, so we basically just have to plug in 4. So 4 cubed is 64, times 2 is negative 128 over 3, plus 4 squared is 16, times 4 is 64. So we have to combine these two, which means I need that to be a fraction over 3. So 64 times 3 is 196, I believe. You might check me there. No, that's not quite right, is it? 3 times 4 is 12. It's 192, isn't it? Sorry about that. And that is an 8. I'm not sure why that became a 3. That was an 8. All right, so 192 and negative 128, I believe that is 64. You can double check that for me. So 64 thirds, which is, actually I don't think it's approximately, it is exactly, 3 goes into 6, 21 times and a third, 21 and a third, is our area between the two curves. So we take the big one and minus the small one. So now that is one that we did by hand. The numbers kind of worked out pretty nicely for us. That is not always the case. So we're going to do one where the numbers are a little bit harder, and we're going to have to use our calculator to find the answer. Okay? And that happens when you can get multiple areas. So find the area bound by these two graphs. All right, so first thing we're going to do is throw those into our calculator and graph them. So go to symbolic view. So I've got the first equation here, 1/3 x cubed minus 2x, and the second one, 1/4 x squared. We're going to graph those. So you can see there's an area here, and there's an area here. All right, I'll draw a quick sketch of that. So we've got the parabola. And then we've got the cubic, which comes up, down, and then back up again, roughly. Now, this is different because here you can see the cubic is on top, the red one, and the quadratic is on bottom. So big, small. But then over here, they switch places. So here the quadratic is on top and the cubic is on bottom. So that means we're going to have two different integrals. So the first one is the integral from a to b. So for our first region here, this one, the cubic is on top. So it's going to be f of x minus g of x. Well, I'm not sure why I put a b there. That's the first area. The second area, they're going to have to switch because now the quadratic is on top. So we're going to take the integral, but now we're going from here to here. So that will be from b to a new number c. And now g of x is the larger one minus f of x. And we might want to make a quick, this is F1 in the calculator, and this is F2 in the calculator. That will become important to us in a second. All right, now we're in luck because the middle point is easy to find. That one is 0. If I plug in 0, we get 0. If we plug in 0, we get 0. So B is definitely equal to 0. Okay? But A and C are not nice numbers. So where do they cross? And so for that, we have to use the calculator to figure that out. So go to your calculator, tap somewhere near the intersection. Now that is not good enough. That is not exact. So do not use that number. Go to Menu, Function, Intersection. You want to find the intersection of F1 and F2. So you can either hit Enter or tap on F2, and then it will tell you the exact intersection, negative 2.1030. Now, I don't want to remember that number, so if you don't move anything and you hit Home, now x, the variable x, has that number stored. You can see there, negative 2.1030, and you can see it keeps going. And so what we want to do is we want to take that value of x and store it. So right here, you can see STO is blue. So hit Shift STO, that is storing it. Now you can pick a letter to store it as. We had A, so let's just call it A. So find where is A is right there. So hit alpha A. So now whenever I use the letter A, it's going to give me that x value that we wanted. So go back to your graph. Now we need the other intersection over here. Okay, so go back to Menu, Function, Intersection, F1 and F2 again, and now that will give us the other intersection, 2.853. I again want to store that, so don't move the cursor at all. Go to Home, hit X. Now X is that new value, 2.8. So hit X, Shift Store, and then Shift, I guess we're going to call that one C, might as well. C is right. Did I hit Shift? I hit Shift. I don't want to hit Shift. I want Alpha. So Alpha, C, Enter. Now C is stored as that 2.8. So now we simply have to type this into the calculator, and it will give us the answer. So go to the definite integral. From A, so type in A. Oh, that is not what I wanted. Escape. Alpha A. To 0. We need to do F minus G. Well, that's F1 minus F2. So type in F1 at x minus F2 at x, comma dx, minus the integral. We're going to go from 0 to c now, so alpha c. And now we have to do F2 minus F1, so alpha F2 at x minus alpha f1 at x dx. And that will give us the answer. Invalid input. Give me a second. Sorry about that. The calculator wasn't quite doing what I thought it was. There's a slight inconvenience here for us, but no matter. We did pretty much do it all right. So the integral from a to 0 of f1 at x minus f2 at x dx. Now here's where we had a problem. If I hit dx, and then if I hit the minus or the plus sign, that is still sort of inside the dx, and that was the issue. So what I might recommend to make sure that doesn't happen is just hit enter right now. That will give you the first area, this one here, and then do your second integral. So from 0 to c of f2 minus f1 dx. Hit enter. And then we simply just need to add those two together. So if you click that one, hit copy. I think I may have said minus, but we do need to add them together. Plus, and if you just tap that one, hit copy. It puts it there. It uses all the decimal places for you. Hit equals, and we have our answer. Take 3 of them, 6.571. All right, so this is equal to 6.571. So that's how you can do more complicated areas that have 2 or even more regions. Just make sure you're doing big minus small, and that can flip-flop. So that's how we find the area between two curves. Area hopefully makes us think of antiderivatives and integrals.